Welcome, everyone. I'm Tongwei Ren from Worcester Polytechnic Institute. Today, I'm going to present our paper on analysis of first-party cookie exfiltration due to CNAME redirections. This is a paper advised by my advisor, Professor Lorenzo Carli from Worcester Polytechnic Institute, and Professor Drew Davidson from University of Kansas, co-worked with Alexander Wittman from University of Kansas. In this paper, we perform a large-scale analysis of the impact of advertising-related CNAME redirections on cookie propagation. Our data confirm that a non-negligible fraction of the Alexa 10,000 websites perform such redirections, consistent with prior studies. We show that in a number of sites, the deployment of first-party redirections cause sensitive cookies to leak to third-party advertising domains. We also find that the ability of blocking these exfiltrations vary between browsers. So what's CNAME cloaking? By using CNAME redirections, the third-party domain gets cloaked as a subdomain of a first-party or trusted third-party, and thus has the same powers as the true first-party or trusted third-party. This is called CNAME cloaking, which is a problem that has been observed in the last years. For example, ad.advertise.com will be blocked by the block list. But using CNAME cloaking can let it pass the block list and successfully delivers the advertisement to the example website. In this example, the example website is a first-party domain, and ad.advertise.com is a third-party subdomain. It uses a first-party subdomain, which is ad.example.com, to hide itself. Thus, ad.advertise.com is also a cloaked domain. The CNAME redirection here redirects a first-party subdomain to a different domain. We call it first-party redirection, and we call advertiser's root domain third-party domain. CNAME cloaking is already a problem that many people pay attention on, and there are already some studies on its spread. However, compared to the existing studies, we are most care about the impact of CNAME cloaking on cookie exfiltration by blurring the range-based policy, which is a crucial part of website security, such that the motivations for our work include 3 points. First, to understand the trade of CNAME cloaking use over the past several months. Second, to supplement the lack of analysis of the effect of CNAME cloaking on browser cookie policies. Third, to understand the actual effects of existing mitigations against CNAME cloaking on cookie exfiltration. We collected our data in both June and December 2020 using a HPC cluster in University of Kansas. We used our automated tool built by using singularity containers and Selenium to visit Alexa top 10,000 websites. And for each website, we visited the homepage for 30 seconds and stored all data into MongoDB by using Medium proxy. We targeted Alexa top 10,000 websites, minus the websites that failed to return any content or returned HTTP error. By the end, we successfully visited around 9,500 websites in June and 9,600 websites in December. The below table is a summary of our dataset. For both June and December, we collected more than 1.5 million requests or responses. And there are almost 190,000 first-party redirections in June dataset and 200,000 in December dataset. However, these first-party redirections have various destination domains. So we performed a filtering to get all first-party redirections that high possibly belong to advertisers or trackers. We did this filtering based on the advertiser or tracker domain lists we extract from some public popular ad or track block lists. And finally, shown in the last row of this table, we got around 28,000 redirections for June dataset and 46,000 redirections for December dataset. Like the filtering we did before, we are most concerned about redirections whose destination domains are advertisers or checkers, such that to get accurate and comprehensive information about destination domains of filtered redirections, we did the domain classification. We extract all source and destination domain pairs and did the manually domain checking. Then we divided all first-party redirections into 3 categories. We tag redirections whose source domain and destination domain belong to a same organization as same organization. We tag redirections whose destination domain belongs to an advertiser or checker as external ad or tracking. And we tag all other redirections as other third parties. Below 2 figures show the results of categorization of first-party redirections by category of destination domain. And we can see external ad or tracking slightly increased between June and December from 509 to 513. And the same organization decreased from 416 to 249. The total number among June and December of source domains is around 2,800, and there are around 1,500 overlapping domains between 2 sets. And the total number among June and December of destination domains, which is cloaked domains, is 101, and there are 31 overlapping domains between 2 sets. After finishing the domain classification, in order to learn more about how frequently the cookies are transmitted to external ad or tracking third-party domains, we did our second analysis, cookie lifecycle analysis. We mainly focus on cross-domain cookie transmission. Cookies may be set by the real first-party domain, but sent to the cloaked third-party domain. Like the figure we show here, the cookie is set by the www.ingbank.pl, but sent to the adocean.pl by using Synonym Cloaking. We analyzed the database by taking each cookie key value pair set by the real first party as a unit to investigate cross-domain cookie transmissions. In total, we found 89 cookies in the June's dataset and 108 cookies in December's dataset. By classifying the destination domains of cross-domain cookie transmissions, we got below 2 figures. And we can see external ad or tracking increased between June and December from 27 to 53, which is almost 50% of 108 cookies we found in December. And the same organization also increased from 11 to 20. In order to gain insight on cross-domain cookie transmission beyond each website's homepage, we did a more deeply manual cookie analysis. We randomly selected 62 websites among those found to perform redirections towards domains in the external ad or tracking category, created user accounts on each of them, and recorded authenticated browsing sessions. After that, we located all candidate cookies that are set by the real first party, but transmitted to the cloaked third party, falling in the external ad or tracking category. We then analyzed each candidate cookie to determine if it is to be considered sensitive. Sensitive cookies are cookies which store information pertaining to the user's identity and/or authentication. We divide sensitive cookies into 3 kinds of cookies: information cookie, authentication cookie, and identity cookie. Information cookie contains users some information, like name, email. Deleting authentication cookie will cause the website to ask users to re-authenticate themselves, like re-entering password. And deleting identity cookie will cause the user to log back in by confirming the user's identity without re-entering password. This table shows the results we got from manual cookie analysis. In total, there are 9 websites in June's analysis and 10 websites in December's analysis exhibited cross-domain sensitive cookie transmissions, including 46 key value pairs, and there are 5 overlapping websites between 2 analyses. Besides, authentication cookie is a kind of cookie we pay more attention on. It's used to authenticate client requests and maintain session information, such that the user doesn't need to re-log into the account on each visit. And there are 5 websites in June's analysis and 7 websites in December's analysis exhibited cross-domain authentication cookie transmissions, including 15 key value pairs. And there are 3 overlapping websites between 2 analyses. To be clear, all cookies we mentioned here are transmitted to third-party advertisers or trackers. The results tell us that the Synonym Cloaking can be used to exfiltrate sensitive cookies. In addition, we also did the browser block list evaluation. We selected the Safari and Brave browsers as these have advertised their ability to prevent Synonym Cloaking. We evaluated the effectiveness of them in their ability to prevent cookie exfiltration by visiting and logging into each of the 7 websites exhibiting cross-domain authentication cookie transmission from December's analysis and the recorded browser sessions. The results show that when using Safari, 2 out of 7 instances of exfiltration were blocked. However, when using Brave, 6 out of 7 instances of exfiltration were blocked. In summary, our data confirm that a non-negligible fraction of the Alexa 10,000 websites perform CNAME redirections, and there is 1 decrease between June and December. We show that a number of sites from 6 to 9 between June and December exfiltrate cookies from 30% of 89 to 49% of 108 cookies to add or tracking third parties on their homepage. And sensitive cookies, totally 46 cookies in 14 of 62 websites, are exfiltrated to third parties beyond the homepage. Besides, we also find that the ability of blocking these exfiltrations vary between browsers. For conclusions, based on the results of our analysis, we got some security implications. First, Synonym Cloaking appears to be a feasible means for advertisers to evade block lists when they have the cooperation of first parties. And third parties and first parties are willing to collaborate in ways that blur age-based security. However, the exfiltration of authentication cookies may open the door to impersonation and account takeover, extend the first-party attack surface. Besides, Synonym Cloaking as an aggregate phenomenon has undesirable implications for user security and privacy. Thanks everyone for your listening. There are all contents I want to present today. Feel free to ask questions.